Welcome, y'all, back to some more geometry. We're talking about congruent triangles here. But first, let's kind of define what congruent is. So congruent, again, is two figures that have the same size and the same shape. So we don't know what their exact values are. We just know they're exactly the same as far as the same size and same shape. Now, congruent polygons, again, are shapes. And we're specifically talking about triangles, but congruent polygons is where all parts of one polygon are congruent to its corresponding parts. And I highlight that because this word will be used a lot. Corresponding, we use it again before with angles. Corresponding angles were angles in the same spot, just in a different section. Here, corresponding parts are the same angle, but in a different spot. So for example, here, they're telling us triangle XYZ is congruent to triangle ABC. Okay, so they're congruent. Now, that being said, their vertices will match up letters. So they said X first, so X is congruent to A by corresponding parts. Y is congruent to B by corresponding parts. And then Z is congruent to C by corresponding parts. So those match up, as well as their sides as well. So if you look at the letters, it's XY first. So XY is congruent to AB first right there. AB. YZ is congruent to BC. And then ZX is congruent to CA. Now, the order you say these matter. So if you want to say, hey, segment ZX is congruent to AC, even though those parts are congruent, the way you say it makes it wrong. So it's very important that you also match up the letters. If I want to say ZX, that's fine, as long as I say segment ZX is congruent to CA. CA. That's very important right there. So that being said, hey, these two polygons right here are congruent. So what parts match up to what part? So A should be congruent to which part down here, y'all? Yeah, R. Good. B would be to S, yes. C would be to T, correcto. E, 1, 2, 3, 4, is to B, good, 1, 2, 3, 4, and then D, and I went out of order just to kind of see if you guys pay attention, and D, 2, 3, 4, 5, is congruent to U, good, 3, 4, 5. So as well as their size, so AE, I'm going to write that down, AE, segment AE, is congruent to which segment? And if you said VR, it is wrong. It has to be in that order. 1 to 4, so then 1 to 4 is to RV. RV is very important. Let's go AB. AB is congruent to RS. Good, RS. RS. CB. CB is congruent to TS. Good, TS. DC. DC is congruent to UT. Very important that you match those up, UT correctly. And then the last one would be, let's go DE. DE is congruent to UB. Yes. All right. So that being said, the third angle theorem here says that, hey, if you know that two angles from one triangle are for sure congruent to two angles of another triangle, then by default, the third one also has to be congruent to the third angle. It's called the third angle theorem. Oh, it looks horrible. Let me put the blue. 1, 2, 3. There you go. 3 to 3. Those have to match up. Just like the A is matching up to H and B to I, then what's the left, that third angle, they match up to each other. So you can go ahead and make that assumption. Now, this next part is important now, but it's going to make more sense when we start doing the proofs for these triangles. So if we know that two triangles are for sure congruent, then we can go ahead and then assume that every single part of one triangle is congruent to every single part of the other part of the triangle. So remember, there's 6 parts to a triangle. There's 3 angles and 3 sides. So those 3 angles will match up with 3 sides every single time. So once we say, hey, triangle ABC is congruent to triangle, let's look at our example here. Triangle XYZ is congruent to ABC, then all this, we can assume all this to be true by what's called corresponding parts of congruent triangles are congruent, or CP/CTC for short, or you'll sometimes see like the CP/CT and then are congruent. The same thing. This will be when you do a two-column proof. If I know triangle ABC is congruent to triangle XYZ, I'm just making this up, say it's given, then I can go ahead and say angle A is congruent to angle X. Why? Because corresponding parts of congruent triangles are congruent. I can go ahead and say that every single part of one triangle, but we have to have this part first right here. As we start working on those proofs, and I bring this up now because you will see this again in the next section as well, in the next two sections as well. So it's very important that we kind of start thinking this. Once we know the triangle is congruent, so once this is true, then you can use this as a reason why parts are congruent to each other right here. So it's very important to remember this. All right, so as far as your homework's gonna go, it's gonna look something like this. Hey, find the value of X and Y. Like, okay. So for example, here, we have these two angles and these two angles. And we're gonna go ahead and say the triangle, we got it right here, triangle KJL is congruent to triangle YXZ right here. All right, so let's go ahead and find X and Y. So we can go ahead and say, that means that this part, JL, is congruent to this part, XZ. So if those are congruent, I can go ahead and say 5 equals 2x minus 3, and then solve for 5. So then we divide by 2, we get x equals 4. So that gives us the first answer. Let's find the next one. So these two angles are congruent to each other. So let's see if we can solve it. We can go ahead and say angle K is congruent to angle Y. So I can say y plus 4 equals 2y minus 15. So I'm going to bring the y over here. So minus y, that gives me 4 equals y minus 15. And then add 15 to both sides. That gives me 19 equals y. And that's it. That'll be most of your work will look similar to this. So if you have any questions, let me know, y'all. Bye.